All right, guys, so we're going to kind of continue what we talked about in 9.2 today. We're going to talk more about similar polygons. Today's a little more complex because we're going to have to set up a lot of ratios, but overall the work is easy if you do the setups right. So we're going to talk about a common ratio. It's the ratio of the lengths of two corresponding sides, meaning maybe I've got this small triangle here and this side is 3. And maybe I got a bigger triangle here and the side is 6. Well, I can set up a ratio of that, which would be the corresponding side of 3/6, which would give me a ratio of 1/2. Meaning, like if I told you that this side over here was 4, well, that's half of its corresponding side, which would be 8. Things like that. So we're going to start off by looking at these two quadrilaterals. It says use the similar figures below, so we know they are similar, which means all the corresponding sides are proportional, and we're going to answer the following questions. It says, what is the common ratio of the quadrilateral ABCD to quadrilateral EFGH? Now, this has to be in order. So we're going to take our ABCD and put it over our EFGH. Okay, we're going to have to set up several sides. So that means basically I'm going to put the smaller quadrilateral sides or the bigger quadrilateral sides over the smaller one. Okay, we could do it the other way, but this one tells us to do it this way. Okay, so I'm going to start off by taking side AB and dividing it by side EF, its corresponding side. Okay, so we don't have to write that out every time. That's going to be 5 over 2.5, and then I'm going to simplify. 5 divided by 2.5 would be 2. Then I'm going to continue around. So next I'm going to do BC, which is 6, over FG, which is 3, which also equals 2. And I have to check every one of them. I'm going to take CD 8 and divide it by GH 4, and that also equals 2. And then to check the last side, that's going to be AD 10 over EH 5, which also equals 2, which means our common ratio equals 2. Now, if we already know they're similar, it's always going to be the same, but right now we're just checking, okay? It says on number 2, show that the ratio of the perimeters is the same as the common ratio. So that means I have to find the perimeters. So I'm going to write perimeter of ABCD, and I'm just going to add up all the sides. Let's see, 10 plus 5 is 15. Plus 6 would be 21, plus 8 would be 29. And that's adding them all up. Then I'm going to find the perimeter of the other one, which is EFGH. So let's add all those sides up. It's going to be 5 plus 4 is 9, plus 3 is 12, plus 2.5 would be 14.5. And now I'm going to set up the ratio like I did last time, the big over the small. And 29 divided by 14.5 is again 2. So we have our answer. So the last question on this page says, what is the common ratio of the quadrilateral EFGH to ABCD? So that's the flip, okay? So instead of the big over small, this one is saying EFGH, the small, over ABCD, the big. So we're just going to kind of look at this one real quick, but it's really just going to be the reciprocal of what the ratio was. So I'm just going to do 1. On the other one, we had 6 over 3, but since it's flipped, it'd be 3 over 6, which would simplify to 1/2. Let's look at the next page. Now, we can use that to determine if things are similar. We're going to have to justify our answers. So there's 2 things that have to be true. I don't know if these are similar yet, but I can find out. The first thing I have to check is, are all the angles congruent? Okay, so I can look over here and I know that 90 equals 90, but I have to find the missing angles to determine if they're all congruent. So I know I have 37 and 90 over here, so I'm going to take 180 and subtract 90 and subtract 37. When you do that, you get the missing angle is 53 degrees. So if I look at the other triangle, I know that it has 90 and 53, which must mean that the other angle is 37. So I do have congruent angles. So I'm going to go ahead and put a check there. Now I have to check and see if all of the sides are proportional. Now you do this however you want. You can do big over small or small over big. But whatever you do, do it for each one of them. Okay? So I'm going to do big over small. I know that I have 9 over 6, which if I simplify gives me 3/2 or 1.5. Looks like I have 18 over 12, which if you simplify, you also get 3/2. And a lot of people will stop there thinking, oh, well, 2 are there, so it must be right. Check all 3. The other one would be 3/2, which obviously equals all of them. So that gives us our second requirement. The sides are proportional. And since they are, because all of these are equal, I know that, yes, I have a similar triangles. So make sure and check, because a lot of times one of the sides will just be off just a little bit and you may not notice. So let's look at this one. This question has a lot to it. It says use the similar figures below to answer the questions that follow. So I'm starting off knowing that they're similar, which means all the angles are congruent and all the sides are proportional. So I have quadrilateral EFGH is similar to quadrilateral. Now you have to make sure and go in the same direction. Well, E was the first letter they used. That's the same as A. And then it goes to F, so we're going to go to B. And then it went to G, which means C. And then it goes to D. Okay, now they will not always be in alphabetical order, so you need to be careful there. It says, what is their common ratio? Now, if you notice, we have to find some of the sides in a minute. Okay, so I need to use sides that I already know. Well, I can use any side I want. I'm going to go ahead and say that it looks like we know both of these. Oh, we have a Z over here too. I didn't even see that one. So that's the only one we know. So you have to pick the corresponding sides that both have measurements to find our proportion. Now I'm going to go big over small this time, and that gives me 10 over 2.5. Now you can do 2.5 over 10, just make sure you're consistent and use that every time. Well, if I simplify that, we have a common ratio of 4. Now if you did it the other way, it'd be 2.5 over 10. I'm going to put or here, which would be 1/4. Just kind of like on the first page, it's a reciprocal. So I'm going to stick with the 4, and that's what I'm going to use. So this right here is my key, all right? To find the 3 missing sides, I'm going to need to use that every single time. And it's up to you which one you use, so just pick one and stick with it. Actually, I think I've changed my mind. I'm going to use 1/4 for this one. So I'm going to go small over big, so I need to be consistent. So I need to find X, Y, and Z up there. Now X is on the small quadrilateral, so I'm going to say X over its corresponding side is 12, and I'm going to set that equal to 1/4 because if they're proportional, those are going to be equal. Then it's just like we were doing the other day. I'm going to cross multiply. I get 4x equals 12, and now I can divide by 4 and I can solve for x, and I get 3. Now I'm going to do the y. Now y is on the big one, so it's going to be on the bottom because it's small over big. Well, y corresponds with 3, so I have 3 over y equals 1 over 4. And now I can cross multiply again. So I have y equals 4 times 3, which is 12. And I didn't have to do anything else there to solve, so 12. And then the last one. Now z is on the small, so z is going to be in the numerator. So I have z over its corresponding side looks like 5 equals 1/4. Now I can cross multiply here, and I get 4y equals 5. Now I divide both sides by 4, and I get that y equals 5/4, and that is okay. Now just a bit of advice. Say you did do big over small where we got the 4. If I was going to set up the first one, maybe it'd be it'd be big over small, so it'd be 12 over x, but we only got 4. But remember, 4 is really 4 over 1, so it really would be the same thing, okay? I don't know why I put 4 there. That's an x. Sorry, guys. It'd be 12 over x equals 4 over 1, which would actually be the same thing, 4x equals 12. Okay, sorry about that. It says, what is the ratio of their perimeters? Well, there's no reason to find the perimeters now. I know that the ratio of the perimeters is the same as the ratio we used up here. So it could be 4, or you could call it 1/4. And it says, how do your answers in B and D compare? Well, that's easy. They're the same. All right. Now, that's really the hardest type of question we have, is where they're missing sides. Be careful when you do your cross multiplication, because that's where people are going to screw up. Let's get to our next one. I know this is a long one, guys. Just hang in there. I've got these two pentagons, it looks like. They're irregular. It says use the similar figures below to answer the questions that follow. So again, I already know they're similar, so all the angles have to be congruent and all the sides have to be proportional. Now, they're not going to make us do every one this time, so it's a little bit easier. It says find the common ratio of polygon RSTUV to polygon ABCDE. Well, I have to look for the corresponding sides that both have measurements. Let's see, if I look around, it looks like I've got 18 and 4. So I'm going to come down here and I'm going to write 18 over 4. And then I'm going to simplify. It looks like it'd be 9/2. Okay, don't put it in a decimal because when we cross multiply, it makes it a little tougher. So I know that's my key. Okay, that's what I have to use to solve all the problems that follow. Now that it wants to find x, y. Well, since I did big over small, I'm going to stick to it. Okay, if I look at the other one, to find x, it's on the big one. And its corresponding side from the small one is 3, and that's going to equal 9 over 2. And now I can cross multiply. 9 times 3 is 27, and that's going to equal 2 times x, which is 2x. So I divide both sides by 2, and it looks like x is going to be 13.5. Now I need to do the y. It looks like we actually kind of have an equation or an expression here. It's going to be a little bit tougher, but we did some of these the other day. But I'm still going to take the big one, y over 2, or y plus 2, and it looks like its corresponding side on the other one is 5. And I'm going to set that equal to 9 over 2. And now I'm going to cross multiply. So I'm going to go ahead and put parentheses around that so don't forget. That's 9 times 5, which is 45, which is going to equal 2 times y plus 2. So I need to distribute. So 4y equals 2y plus 4. I can subtract 4 from each side. I'm going to have to come over here, sorry, which is 41 equals 2y. And then when I divide both sides by 2, I get y is 20.5. So just set up your ratios, find that key, and set it equal to the ratios from the other sides that we're missing. Now this has a lot to it. It says quadrilateral ABCD is similar to EFGH. Answer the following question. So since they are similar, all the corresponding sides are congruent and all the corresponding sides are proportional. So I already know quite a bit about this one. Like I know C and G are corresponding angles because they're both 90. F and B are, so if F is 100 degrees, then B is 100 degrees. E and A are corresponding, so if A is 60, that means E is 60. And that leaves me with H and D, and I know they're the same, I just have to find them. Now, to quadrilateral, there's 360 degrees, so I can subtract the 3 angles I know and find the missing angle. So 360 minus 90 minus 100 minus 60 leaves me with my last angle is 110 degrees. Now, I think it asks those for us down there. We found E was 60. We found that G we know is 90, as it was given to us. Angle B looks like it was 100 degrees. And then angle H was 110 degrees. Now we need to find some missing sides, because if you notice, there's 2 missing sides over here on the ABCD, and there's 1 missing side on the other one. So I need to pick a pair of sides that I know. So this time, guys, I'm going to do small over big, and I'm going to keep it there. So if I use 6 and 18, those are the ones that I know, I would have 6 over 18, which is simplified to 1/3. So there's my key. That's the one I'm going to use on each problem. Okay? So let's see. EH is what they want first. I'm going to go ahead and mark it with an X just to make it a little bit easier. Okay? So let's see. I have small over big would be 5 over X. Equals my key 1 over 3. So I can cross multiply and solve. Well, X times 1 is X. 5 times 3 is 15. So EH is 15. Now I'm going to go to the next one, BC. I'm going to go ahead and throw a Y in there just so I know what I'm talking about a little bit easier. So again, I need small over big. That's going to be Y over 9. Equals my key 1 over 3. Now I can cross multiply again. Looks like I have 3Y equals 9. I divide both sides by 3, and I get that Y equals 3. And then the last side I need is AB. Now that's on the small triangle, so I have it right there. Let's see. So I need to do looks like z over 21 equals my key 1/3. So I cross multiply, I get 3z equals 21. I divide both sides by 3, and I get z equals 7. Now it asks at the bottom, it says, what's the common ratio between those quadrilaterals? Well, we already found it. It was the 6 over 18, or in other words, it was the 1/3. Let's flip the page and get this over with. I know this has been long and arduous, but these two problems are pretty easy, but people get confused on them a lot. It says the lengths of the side of a triangle are in the ratio 3 to 5 to 7. Its perimeter is 120. Find the length of the shortest side of the triangle. So there's a trick to this, okay? I don't know what the sides are. I just know that their ratios are 3, 5, and 7. So I'm going to say that I know it's 3 times whatever my ratio is, plus 5 times whatever my ratio is, plus 7 times my ratio, should have a perimeter of 120, and it turns into a fairly easy problem. 3 plus 5 plus 7 gives me 15x equals 120. I divide both sides by 15, and I get that x equals 8. Now that is not my answer. That's just what the ratio is. They want the shortest side. Well, the shortest side is going to have the smallest part of my ratio, so I'm going to take 3 times the x value I found, and I get that the shortest 5's length is 24. So short side, okay? The next question is very similar. It says the measures of the angles of a triangle are in the 8 ratios of 1, 2, 3. Find the measure of the largest angle. Well, guys, this is a triangle. There's 180 degrees in a triangle, so I work it the same way. I still take my ratios, but I take my simplified ratio, and I throw an x on the back of it and add them together. This time, instead, though, I set them equal to 180. So that's 6x equals 180. If I divide both sides by 6, I get my x value of 30. Now, that is not my answer again. It says here that I want the largest angle. Well, the largest angle is going to have to be the one multiplied by 3. So I do 3 times my x value of 30, and I get that the largest angle is going to be 90 degrees. So, guys, we can go over some of this in class tomorrow. I know it can be a little difficult, but do your best on your homework, and good luck.